G'day guys, I've taken apart an ADSL router and I'm going to try to gain serial console access via the UART using the BUSSide. Like I said, I've pulled apart the router and I've identified that there's a few exposed header pins. On the bottom left of the device, you can see in the picture, there's two rows, maybe 10 or 14 pins, probably going to be JTAG with that high pin count. On the right, there's about 5 or 6 pins in a row. That's most likely going to be UART. I've used a multimeter with the device powered off and the continuity test function on the multimeter to identify the ground pins that are in those pins that are exposed. And I've identified the ground pin, I've connected that to the ground on the BUSSide. The remaining pins that aren't ground, I've connected to the GPIOs on the BUSSide, and in fact I've connected them to GPIOs 9, 8 and 7. I'm going to start the BUSSide now. It's on dev TTY USB 0. The intro screens come up and I'm going to run a command UART pass-through auto. I don't know what the pinout of this UART is, or even in fact if it is UART, but I'm going to let the BUSSide try to figure that out automatically. I'm going to power on the device before I run this command, so I'm going to power on my ADSL router, powered it on, and I run the command. What it's doing now is it's listening for signal changes on that UART. And if it identifies signal changes and there's enough of them, it'll try to see if it's UART. In fact, it has detected that it is UART. 38400 baud rate on GPIO 9, your standard 8N1 line settings as well. So that's your receive pin. To detect the transmit pin uses a different approach. And to do that, we need to wait until the UART isn't transmitting any data. And its easiest way to do that is wait for about 60 seconds until the device powers up and gets into some sort of login screen or other sort of state where it's not transmitting boot messages and so forth. The way that it detects the transmit pin is it tries each pin in turn and it sends a few characters over that transmit pin with the appropriate line settings. If the receive pin gets an echo that replicates what's been transmitted, then we know that we've got the right transmit pin. So we just need to wait until our UART is idle. Again, simplest way to do that is just wait a little while, and now we're going to try to discover the transmit pin. It's found the transmit pin in fact on GPIO 8, GPIO next to it, and it's entered pass-through mode. So all we need to do now is hit enter a couple of times, and great, we've got a shell. How easy was that? So it automatically detected the line settings, it automatically detected the transmit and receive pins and the pinout and dropped us immediately into a shell. So thanks very much for watching. We do training at InfoSect here in Canberra, whether it's interfacing with IoT devices and using the BUSSide or code review, exploit, dev reversing and so forth. Go to the wiki for the information about the BUSSide and how to use it. Other than that, I'll see you guys next time.